Hello everyone. Now onwards we are going to start igneous petrology. So I'll discuss about different forms, texture, structure, and then we'll talk about the phase rule. Then we'll go for the different classification of igneous rocks, and then we'll discuss about some rock types. Okay. So the starting here igneous. So what do you mean by igneous rocks first itself? What is the definition of igneous rock, or what are the characteristics so that we can name it as a igneous rock? Okay. What are the characteristics that make it different from other rocks like sedimentary and metamorphic rocks? So igneous means it is formed from solidification of magma, consolidation or solidification of magma. Magma or lava, right? Then what is magma? What is lava? Magma is, as all of us know, that is hot molten rock matters. Hot molten rock matters, right? What is lava? When magma erupts to surface, by volcanic vents or due to volcanic events, okay, when magma erupts to surface, we name it lava, right? As I have told you, the igneous rock means it should be formed as a consolidation or solidification of magma or lava. What is magma? That is hot molten rock material. And what is lava? When magma exposed to surface or erupted to surface, we name it as lava. Accordingly, the igneous rocks, they are classified into two types. Actually, we can say it three types, but broadly we can classify it as two types: plutonic and volcanic. Plutonic and volcanic. One more type is there, as I have told you. I can say igneous rock, either that is formed from magma or that is formed from lava. When it is formed from magma, we are naming it plutonic igneous rock. When it is formed from lava, we are naming it volcanic igneous rock. Again, this plutonic, and there is one more rock type, one more group we can say, that is known as hypobasal rock. So what does that mean? Plutonic, hypobasal and volcanic. Plutonic means it is at greater depth. Hypobasal means it is your less than 2 km from surface. These two are forming in deeper condition only. They are not exposed to, they are not crystallized at the surface, or they are not solidified on the surface. Okay, these two are beneath the surface. These two are crystallized from magma itself, right? Not lava. These two are crystallized from magma. But plutonic these are occurring at greater depths, like 7 to 18 km. The maximum depth can be 7 to 18 km for these plutonic rocks. These hypobasal rocks, they are occurring from near surface to less than 2 km, right? And the volcanic rocks, they are formed at the surface. Okay, they are formed at the surface. So these are three. We can divide the igneous rock into three broad classification: plutonic, hypobasal and volcanic. Plutonic means much deeper. Hypobasal means near surface, volcanic means above surface. Okay. Then what are the characteristics that differentiate igneous rocks from sedimentary and metamorphic rock? Okay, we can say in igneous rock, how we can differentiate igneous and sedimentary? See, in sedimentary rock there is a fundamental structure. Sedimentary rocks, they are having a fundamental structures called bedding. Right? These are deposited. Sedimentary rocks means these are as a result of sedimentation, then consolidation, compaction, etc. Diagenesis. Those are the processes. We are going to study that in sedimentary petrology. So, sedimentary rocks, these are as a forming as a result of sedimentation. Metamorphic rock, metamorphic rocks, this is produced due to change in temperature and pressure condition. Change in temperature and pressure condition. This temperature and pressure, this parameter, every rock is forming at a certain temperature and pressure condition. Like igneous rocks are also forming at certain temperature and pressure condition. Sedimentary rocks are also forming in surface condition, means there is also certain temperature and pressure condition. So when that temperature and pressure condition is changed for that rock, okay, that rock will undergo some changes. That rock will undergo some changes. It will modify its mineral assemblies, thereby forming a new rock type that is known as metamorphic rock. Okay, the composition is not entirely changed. The composition is altered, right? So sometimes it may be recrystallization or anything we are going to describe in details in case of metamorphic petrology. Okay, but the thing is that in sedimentary rock we are finding layers. In metamorphic rock we are finding something called foliation. In metamorphic rock we are finding something that is named as foliation. What is foliation? These are planes. These are foliation planes. Also, like we are finding layers in sedimentary rocks, we are finding foliation planes in metamorphic rocks. But these two things are absent in igneous rocks. These two things are absent in igneous rock. Why? Because these are not due to sedimentation or not due to this metamorphic, that is temperature pressure change. These are formed directly from the magma. These are formed directly from the magma. Also, we can name it as primary rock. Why? Why it should named as primary rock? Because the sedimentary rocks, they are formed as a the process of formation of sedimentary rock, that includes the first step, which is named as sedimentation. So from where this sedimentation came, from where these sediments came, these sediments come from a parent rock. So where these parent rocks came, from where these parent rock came, so that should be formed by this magmatic activity. That should be formed by this magmatic activity, right? At first igneous rock should be formed, then it should be eroded, weathered, eroded, and then transported, then get deposited in form of sediment, then that undergo compaction and consolidation to form sedimentary rock, then that will be undergo temperature pressure change to form metamorphic rock. Okay, we can name it as rock cycle. Okay, you can name it rock cycle. I am giving you some idea about that. Rock cycle. So what is rock cycle? At first what happens? Igneous rock is formed from where? From magma. From magma, when it is solidified, to form igneous rocks. These igneous rocks, they will be weathered, or you can say weathered, then eroded, then transported, then deposited. Okay, these parent rocks, they got weathered, then eroded, transported, deposited. Then the next process, sedimentation, then compaction, consolidation, diagenesis, etc. Then they result in formation of sedimentary rock. Then they result in formation of sedimentary rock. These igneous rocks, they weathered, eroded, transported or deposited, then they will form sedimentary rock. Can these sedimentary rocks again got eroded and then form new sedimentary rock? Can it happen? Obviously yes. The parent rock should be eroded. The parent rock should be maybe igneous, maybe sedimentary, maybe metamorphic. But the first sedimentary rock formed, that should be originated from igneous rock. Okay, the first sedimentary rock in the earth, let's say consider the first sedimentary rock that formed in the earth itself. Where it came from? It should be from weathered material which are deposited. So where this weathered material came? From where this weathered material came? They come from some primary rock. That primary rock is your igneous rock. Okay. So igneous rocks, they undergo this process, then they form sedimentary rock. Then what happens? This sedimentary rock, they are forming at certain temperature pressure condition. Their sedimentary rocks are deposited in basins. So the basins, they are having some certain temperature and pressure condition. When the temperature and pressure change, when the temperature and pressure condition changes for that rock, they will undergo metamorphism to produce metamorphic rock. They will produce metamorphic rock. So the sedimentary rock, they are deposited in certain temperature and pressure condition in the basins. They undergo temperature pressure change to form metamorphic rocks. Can these metamorphic rocks directly form from igneous rock? Can this happen? The answer is yes. Why? This igneous rock, they are forming at certain temperature and pressure condition that may be lower or higher. Okay, the temperature change should be maybe higher or lower, right? Like this igneous rock is formed at, let's say, 1100 degrees centigrade. Then when it exposed to surface at 1100 degrees centigrade, for example, at 1100 degrees centigrade, this igneous rock is formed under this is very high temperature. That means it should be plutonic. That means it is occurring at depth. Okay. So the plutonic rock having this much temperature is formed as an igneous rock. What happens when it is exposed to surface? When it is exposed to surface, what happens? It is subjected to temperature of nearly 30 to 40 degree centigrade at surface. Okay. So the mineral assemblages which are stable at this temperature pressure condition, when they are at plutonic, when they are in plutonic condition, or when they are at depth, the temperature pressure which result in formation of this rock, when this is subjected to surface condition, the temperature pressure condition at the surface, okay, that is not favorable for those mineral assemblies which are occurred here at this stage. Okay, what is a rock? Rock is a assemblage of mineral. Rock is an assemblage of minerals. So many minerals, they combine to form a rock. On the basis of mineral composition only, we are naming or defining a rock, right? So those mineral assemblages which are formed at this much higher temperature pressure condition, they are no longer stable at this temperature pressure condition. So what happens? They will alter, they will change. So when they will change, they will produce another mineral assemblage. They will produce altered mineral assemblage to produce another rock which will be named as metamorphic rock. Similarly, this rock which is forming at the surface, if it is subjected to high temperature pressure condition, then what happens? I am not going to melting, right? Let's say the rock is not melted, right? I am talking about from 30 degree 40 degree to let's say 200 degree centigrade or 400 degree centigrade, like that. Okay, so what happens, the temperature pressure condition at which this rock is formed earlier, now it is subjected to higher temperature pressure condition. So at higher temperature pressure condition, the minerals which are formed in this case at this temperature, at surface temperature pressure condition, the mineral assemblages which are formed, these are no longer stable at this temperature. Okay, so then what happens, if they are no longer stable, they will alter to high temperature polymorphs, or they will alter to high temperature minerals, right? So what happens, the mineral assemblage is going to change. When the mineral assemblage is going to change, we will name it as a different rock. And that rock will be your metamorphic rock. Okay. So this igneous rock can get weathered and all these processes, then it can be converted to sedimentary rock. Not converted, new rock is formed, that is sedimentary rock. From sedimentary rock we can go to metamorphic rock, or directly from igneous rock we can go to metamorphic rock. Okay. Next thing, if whether this metamorphic rock is not going to erode. Okay, I am asking whether this metamorphic rock is not going to erode. The answer is yes, this metamorphic rock can get eroded. If this is getting eroded, then what will happen? It will undergo again these processes, weathered, eroded, transported, deposited, sedimentation, compaction, consolidation, etc. So this metamorphic rock can also produce sedimentary rock, and similarly the rest of the process they can be continued, right? From igneous rock we can find out sedimentary rock, from igneous rock we can find out metamorphic rock, from metamorphic rock we can find out sedimentary rock, from sedimentary rock itself we can find out another sedimentary rock when it is getting eroded and then deposited in different environment, so we can get that. And this sedimentary rock can undergo change in temperature pressure condition to produce metamorphic rock. Then the thing is that, is this cycle, if it is ended at here, metamorphic rock, you can see now till this it is ended at metamorphic rock. From magma it got igneous, then sedimentary, and then metamorphic to sedimentary, then metamorphic. So the end point is metamorphic. If it is ended here, it should not be a cycle. I am talking about rock cycle, it should not be a cycle. Then what happens? There must be some condition that these rocks are going and forming again magma, right? The end points should be connected. This metamorphic rock, if I'll change the temperature pressure more, if I'll increase the temperature more, if I'll increase the depth more, right? Either for this metamorphic rock or this sedimentary rock or this igneous rock itself, right? If I'll change the temperature pressure of these rocks, if I'll change this temperature of these rocks, what will happen? They will produce magma, they will produce liquid state, they will transfer into liquid state, right? If I'll increase the temperature at a higher rate, as I am telling, the rock is formed at 40 degrees centigrade and I am increasing its temperature to, let's say, 1300 degrees centigrade. So what will happen? That will converted into melt, that will be melted. So that melt will again called as magma. That magma again recrystallized to form igneous rock, and then cycle continues, right? So what is rock cycle? From magma we are getting igneous rock. When it is solidified, then this igneous rock, it is having some mineral assemblies. Okay, when it is getting eroded and transported and deposited, they will form sedimentary rock, or when they are undergoing temperature pressure change, they will produce another mineral assemblage to produce another rock called as metamorphic rock. Similarly, the sedimentary rock can get metamorphosed. Again, if I increase the temperature of this metamorphic rock, because it is having certain temperature pressure condition, if I increasing its temperature, whether at this stage metamorphic rock, whether at this stage in sedimentary rock, or whether at this stage igneous rock, they can produce melt. They can produce melt to produce magma again. Okay, so this is your rock cycle. This is your rock cycle. Okay. So now we are dealing with this igneous rock, and I have defined what do you mean by igneous rock and how many types you are getting on the basis of depth, or I can say whether it is crystallizing from magma or whether it is crystallizing from lava. If it is crystallizing from magma, we are naming it as igneous rock or plutonic igneous rock, or if it is at near surface, we are naming it as hypoglycal igneous rock. Then if it is occurring at the surface due to volcanic eruptions, we will name it as volcanic igneous rock, right? And then I have told you regarding what are the characteristics those igneous rocks should have. First of all, it is having what? Crystallized, or it is having what? Crystallized structure, or why crystallized means it is having entirely grains. It is having entirely grains because those are solidified from the magma. Those are solidified from the magma. These are having entirely what? Mineral grains. Okay, or you can say, we cannot say crystal because it is not always that they are forming crystal. That should be a mineral. I have already told that a mineral can be, a crystal is a mineral. Okay, crystal is a mineral, but all minerals are not crystal. When the mineral is having perfectly developed phases, then it is named as crystal. So the igneous rock, it may contain crystal or it may not contain crystals, but it should be entirely grains, and it should be entirely minerals. It should be entirely from consolidated from the magma. There is no process like precipitation or you can say compaction or anything, cementation. Like we are not finding any precipitated material, or we can say cements. Okay, we cannot find this. These are occurring in sedimentary rock. To bind the grains, right? In case of sedimentary rock, when the grains are deposited, this cement or this precipitated cement, they will act as binding material to bind together the grains. Okay, but in case of igneous rock, we cannot find them. Second thing, what I have told, that their lack of foliation and bedding. We cannot find bedding there, right? As we are finding in sedimentary rocks, different layers, we cannot find bedding. And as we are finding foliation in metamorphic rocks, foliation plains, we cannot find these foliation plains also in igneous rock. Okay? Okay. So next we will go to forms of igneous rock. These are the criteria on the basis of which you can differentiate between igneous and sedimentary and metamorphic rocks. Okay. Next we will go to different forms of igneous rock. Okay. So what are different forms? The igneous rock can be divided into two forms: extrusive and intrusive. Extrusive rocks and intrusive rocks. These extrusive rocks what I have told previously, that is your volcanic rock, that is your volcanic rocks. Why extrusive? Because it is exposed to surface. The magma comes out to surface, then it will produce rock. Okay, the magma from beneath the surface or from the magma chamber, it will come to the surface, it will move out to the surface and then solidified to form this kind of rock known as volcanic rocks. And as I have told, they are resulted from lava. They are resulted from lava, not from magma. In case of intrusive rock, what happens? They are deeper rocks. They are deeper rocks, or we can say, we can divide it into two types: plutonic and hypobasal. Plutonic and hypobasal. Okay, plutonic and hypobasal. So these two rocks, they are resulted from magma. Okay, when it is crystallized from lava or solidified from lava, we are naming it extrusive or volcanic rocks. Intrusive means, what do you mean by intrusive? What happens? Some rocks are there, some parent rocks are there, some host rock, we can say, some host are there. Okay, the magma got intruded, and solidified, right? Previously there are some parent rocks were there. Previously a host rock is there. Within the host rock it is entered and get crystallized and get solidified. So we are naming it as intrusive rock. What happens in case of extrusive? The magma comes out to the surface. These are the parent rock. Magma comes out to the surface and it will form igneous rocks here on the surface. It will form. This is the volcanic eruption. Volcanic eruption is taking place here. What happens? Magma comes out to the surface, become lava, and that lava that will flow and or that will get solidified there. We'll see what type of structure will be there. But when this magma come out to the surface and form igneous rock, we are naming it as extrusive igneous rock or volcanic igneous rock. When it is crystallized or solidified inside the host rock, we are naming it as intrusive igneous rock. Okay. Then we'll go for different forms of this extrusive and intrusive rocks. Generally, these extrusive rocks, what we are finding while talking about different forms of extrusive rocks, or we can say different structures what we are finding in extrusive rocks. So first of all, as I have told, lava erupted and they will flow. Flow structure we can say, or we can also read it in the structure also. Okay, igneous structure, lava flow, right? It can be extrusive rock. It is an extrusive rock. It is an extrusive rock. Okay, this lava flow means lava comes out to the surface and flow. Why this is flowing? Whenever we are talking about flowing nature of a fluid, which property is coming to our mind? Viscosity. Okay. So what do you mean by viscosity? Viscosity is the property of the liquid. It is not the property of medium, right? It is not the property of host rock. It is not the property of medium. It is the property of the magma. It is the property of the lava. It is the property of that fluid, right? What we are talking about. So the property of the fluid that resist its flow. Viscosity means it resists its flow. Okay, that means whenever a fluid cannot flow easily, we can call it as highly viscous. Okay, like oil and water. Which of them will be more viscous? Oil will be more viscous. Why? because water can flow easily.